Olá, boa tarde, pessoal. A gente está aqui para uma palestra do professor Alexander Nolte, então agradecer a presença de vocês e do professor Alexander Nolte, que é professor da Universidade de Eindhoven, Universidade Técnica, e também afiliado à Universidade Carnegie Mellon dos Estados Unidos, e ele pesquisa sobre hackathons e aplicados a pesquisa científica com computação de alto processamento, astronomia. Ele já trabalhou em vários eventos desses, né, organizando e pesquisando a respeito. É da área de interação humano-computador. Ele está aqui por ocasião do AI Ed, que é um evento que está acontecendo aqui em Recife essa semana, e nessa sexta-feira a gente está organizando juntos um hackathon voltado para AI Literacy, né, que é sobre uso de IA na educação, né, e aprender sobre IA para usar nesse contexto. E eu vou passar a palavra para Alexander agora, né, eu vou passar para o inglês para iniciar aí a palestra. Mais uma vez, obrigado aí pela presença. So, Alex, just introduced you and said very nice words about you in English.
Yeah, sure, I
and
bet.
Now it's with you, and thanks again for your talk.
Yeah, thanks for the invitation. Thank you for coming. Yeah, I've never been introduced in a language that I don't understand, so I have no idea what he said. I hope it was good stuff. If it wasn't good stuff, then you can tell me later in secret, and I will talk to him then about it. Anyways, so yeah, thanks for coming. If you have any questions in between, right, just raise your hand, just shout, just do whatever, because we're such a small group, it's okay. You can also move a little bit further front if you want to, because it's kind of weird that I appreciate that you're not sitting all the way in the back, because that's what I expected. But if you want, you can come a little bit closer to make it make it a little bit cozier. Yes, perfect. Thank you. All right, so yeah, as Kiev most likely said, I will be talking about advancing scientific software through hackathons today. So basically the whole talk will be centered around these two topics, right? So first scientific software, and then the second one, hackathons. I also don't know how much he told you about this already. I assume he told you this part here, because I heard like Eindhoven and things. So yeah, I am currently assistant professor in Eindhoven at the Software Engineering and Technology cluster. And I also still have an affiliation with Carnegie Mellon University at the Societal and Societal Systems Department. And what I study is mainly situations like this. Well, not quite like this, obviously, because the robot is sort of the representation of what we know as AI today. In the future, it might be like this, but right now it's not. So basically, I'm interested in generally studying settings where people develop software together. That's basically it. So if you're a small team, if you're a large team, doesn't really matter. If you develop some form of software together, that's what I'm interested in studying. So to the actual topic of the talk. As we all know, science is kind of powered by software, right? It's literally in everything that you can imagine, right? The top left you will probably have seen before, right? James Webb Space Telescope. So it's from like astrophysics to particle physics to oceanography to I don't know what. All these people that do their science need to use software in one capacity or the other, right? For example, for the space telescope, of course, in order to change its trajectory and look at a specific area of the universe, you need to send some command up there so that it moves around in a way. Then it's going to collect data. The data needs to be sent back. Then someone needs to analyze this data. All of that is somehow powered by software. But of course, when we talk about scientific software, we don't talk about stuff like, let's say Word, because everyone uses Word, right? We talk about something a little bit more specific. If you start looking for definitions, you will most likely be surprised, like I was, that there are, surprisingly few, and they're surprisingly different also. So I kind of made up one, more or less, as a combination of all of them that were out there. So basically, we don't talk about software that everyone uses, and we really talk about software that is specifically designed to support, enhance, and facilitate scientific research. So basically, that is done for researchers, that researchers use across different disciplines to perform different types of tasks. And these tasks can involve, as I said, moving a telescope around, but they can also be, of course, related to data analysis, simulations, and many other things that scientists do in their work. And I also brought a few examples here. I assume some of them you will know, right? Pandas, how many? Who has used Pandas before? Hands up. No? Okay. Jupyter? Yes. Okay. BTK? Okay, here it becomes thin, I assume, right? Because none of you is a biologist or an astronomer. But any case, it's just to show you that also this kind of software can serve very different purposes. There is stuff that is very domain specific, like for example, for astronomy or also for biology. But then there's also things that are more general purpose, like a visualization toolkit, like Pandas or like Jupyter. So now you can, of course, ask, yeah, well, it is software after all, right? So what makes scientific software so damn special that it's worth to talk about it separately? Well, the first thing, hello, welcome. The first thing that makes scientific software special is that it is oftentimes developed actually by scientists. And there's a very good reason for that, because if you think about, so who here is in like a computer science domain? Who studies computer science or works in computer science? What is it then? Is it computer science? Is it software engineering? What is it? Information systems. Okay, but any case, yeah, it's close enough, right? So what you will probably do when you're a software engineer or something, you typically talk to your users, you try to understand what they do, and then you try to build software for them, right? That's kind of sort of the typical process in, I don't know, whatever way, Scrum or I don't know, doesn't matter, right? That is a little bit difficult in this case. Because, I mean, you can probably most likely understand how an office works, so how they organize their work, right? Try to understand gene sequencing instead. Or try to understand whatever obscure algorithm some poor PhD student somewhere in some department of science wants to develop in order to advance their science, right? That's difficult. So most of the time what happens is the scientists develop the software themselves. But that is, of course, problematic because, I mean, chemists, biologists, or astronomers, or whatever, they're not trained in software development. So they kind of develop software, but that software, of course, comes with all sorts of problems. It comes with issues related to reusability afterwards. There's oftentimes poor documentation. There's no testing. And when they put it open source, I mean, their definition of open source is oftentimes, oh, I have a GitHub repository that everyone can access, and so now it's open source. But of course, you know, that is kind of not enough, really. So the one thing that makes scientific software special is the people that develop it, which again are oftentimes amateurs in terms of software development, not in terms of their regular profession. The other thing is that the incentives are different. So when you think about you're a software developer, you are getting paid and your incentive is to develop that software. Scientists don't get paid or like have as a main incentive to develop software. Their main incentive is we want to publish papers. We want to publish many papers. We want to get many citations. Our H-index needs to be super high. That's what we want to do, right? So there's also very limited incentives for these people to develop what we would call probably good software in the sense of reusable, documented, and all these kinds of things. And then also, well, the funding schemes are often not for that. The funding schemes are often meant for, I want to advance science. I want to develop a new cancer drug. I want to, I don't know, study this specific area of the sky, something like that. That's what you get funding for. You get funding for scientific discovery, but you don't get funding for developing software that afterwards people can reuse. It has changed a little bit in the sense of that this oftentimes becomes part of the whole funding scheme, but what definitely is still lacking is the long-term sustainability plan. So it's oftentimes that the software, at least the development, the initial development is kind of being paid, but then it's out there and no one maintains it anymore. So how do we deal with this issue then? Well, oftentimes what we do is we perceive that thing then as a community effort, as you would in open source, right? But that, of course, means then that you would need to have some form of a common code base. So the idea is really that you as the scientific community, you as the, I don't know, biology community, the neuroimaging community, the astronomy community, whatever, you have some form of understanding of what kind of software is out there. And you know who developed it, you know how to connect to it, you have some form of a common code base that everyone is kind of working on, right? That would be the idea, because then it can also live on over time. The first PhD student that developed something can then continue, or the second PhD student can continue developing what the first PhD student worked on, and so on. Or you can also exchange software and things between labs. So when you're working on something here and I'm working on something in the Netherlands, then we can share that and we can develop on a common code base. There should, of course, also be knowledge exchange, right? So oftentimes what you deal with is you deal with instrumentation that is very specific, that produces very specific output formats that even if I would give you the data, you will probably not even be able to use it because you don't know what it means. Right? So you also need to develop some form of common practices of how we collect the data, of how we store the data, of how we analyze it, what kind of tool chains we use, all these different things. And then, of course, you want to foster the community, because it is a little bit of a, exchange all the time, because PhD students or students in general have a certain period of time that they spend, and then there is the next one, and then there's the next one. So you want to grow that community and want to sort of have this continuous evolvement of that. That's at least the theory. That's what you would like to have. What we see oftentimes is more something like this, and that is courtesy of Kiev's previous master student, now my current PhD student, Lavinia, who studied here. And this is of all the ecosystems from the room acoustics community. You can ask me later why of all the things we study the room acoustics community. It's a bit of a longer story. Anyway, so what you can see here is you kind of have sort of two repositories that kind of stick out, right? That are old enough in terms of age, so they have been around for quite some time. They have, when you look at the colors, they have a certain amount of commits. So there is activity, there's stuff happening. You also have a certain amount of contributors, although when you look at the numbers here, it's already pretty small, right? So you have like, I don't know, from 4 to 24. Like you would probably want to see something here more in the hundreds of people in order to have a really sustainable community. And then what you also see is a lot of stuff happening around sort of this area, right? So young, tiny little projects that have a few commits and that then also have very few contributors. And that is oftentimes, I don't know, students that do a thesis. So you have like, I don't know, a master student that develops a piece of software, does a few commits, puts it there, and then no one builds on it and uses it ever again. So that's kind of the situation. And this is where I think, or where we think, that hackathons can potentially help these communities. Who of you here knows what a hackathon is? You don't have to raise your hand, thank you. Okay, so we have 1.5 arms. No one ever participated in one? No? Okay, good. So then, for the first time ever, I think, I can go through this definition without people already knowing what I'm talking about. So you don't have to read the entire thing. I will just go through the details, because also, I don't know what happens here in Brazil, but in Europe at least, the term has been sort of hijacked by a lot of people that are using it basically as, oh, I want to have something developed and I don't want to pay anyone for it, so I organize something that I call a hackathon, which is not a hackathon. Right? So, any case, when I think of a hackathon, what it is, it's a time-bounded event, right? Typical, like, time frame is 1 day, 2 days, something like that, right? That's a more common format. If it's online, it sometimes takes a little bit longer. It's participant-driven. So it's not like your typical class or a typical workshop where the situation is kind of like it is right now, right? So I'm driving the conversation and you're kind of listening. It is driven by the people that come, so they do something. They form teams. So it's not an individual event. It's not like I work alone on something. It's always people working together in teams of varying sizes, typically like, I don't know, 3 to 5 or something like that. And they work on a project that interests them. So again, it's not a class assignment. I'm not saying that class assignments can't be interesting to you, right? That can happen. But here it's a project of your choice. It's what you would want to work on. And then you don't only talk about it, because it's not just a brainstorming session. It's not a session where you just talk about stuff. It's a session where you have to develop something and create an artifact. It's intentionally a little bit vague. Of course, this artifact is most of the time software, but it's not always software. There can also be hackathons around, I don't know, robotics, or I've seen people hack on Wikipedia pages, or on poems, or on legislation, whatever. But in the end, you have to have something that you can present. There needs to be some form of artifact. They come kind of out of Silicon Valley a little bit. I mean, of course, these events have happened before. They were just not called that. But this sort of specific flavor, this specific type, comes sort of out of the early 2000s and was really kind of a competitive coding event. So people just went, and there was pizza, and there were friends, and you could do something, you developed something, and then everybody was happy, and maybe you got a job out of it afterwards. That was how it worked. But then other communities decided, hey, this is a cool format to do all sorts of stuff. So it kind of spiraled a little bit out of control. You might notice 48 on my shirt, because before going to the Netherlands, I was in Estonia, and their hackathons were very much tied to entrepreneurship. So they basically organized these as an on-ramp for startup founders. So startup founders wanted to be, they could come there, they could develop a first product, they could talk to investors. It was really sort of in this whole startup ecosystem. But there's also events that corporations organize, both internally and externally, Microsoft and Google probably being sort of the more prominent ones. There's civic and open data events. That is something that I brought from the US, more or less. I'm not sure. Is that a thing here? Like, are there civic data events here? All right, yeah. So basically the common thing here is oftentimes there are data sets about, I don't know, the city, for example, like pollution levels, or I don't know, how crowded public transport is and stuff. And these data sets lie around and no one does anything with them. So that's how they came up with the idea, hey, let's organize some of these civic and open data days and actually use it for anything and come up with something useful. And then you also have on the top, these are events that are oftentimes related to colleges. That's also a very deeply American thing. And then you have the scientific events. And that's where it becomes sort of interesting for this specific talk. So since no one has been at a hackathon here before, I will give you a little bit of an insight of what a typical event looks like. This is from the entrepreneurship space. So I just want to give you sort of the cornerstones of what you typically find in an event. Not every event looks like this, and you can design an event to have a specific sort of kind of atmosphere, to have specific outcomes. That is kind of the idea of it. But here it was basically a 48-hour in-person hackathon for entrepreneurs working on projects related to cybersecurity. That was an event that I co-organized, I don't know, before COVID, like, I don't know, 2019 or whatever. And the agenda is, in the beginning, you have people, like you have a big lecture hall, something like this, just with a few more people. And everyone can pitch. So you can just come up and be like, hey, I want to work on project X. And then you get a little poster, you go to a little corner with your poster, and then you stand there. And then whoever doesn't pitch can shop around. So they can just look around, which one do I like? And if you gather enough interest in your idea, then you have a team. And then you start working on stuff with that team during these 48 hours. And in between, you then have regular checkpoints. The idea basically being that you all come together and everyone presents what we have done, what were our problems. Serves multiple purposes. One purpose is that, of course, when you are sort of entrenched and work with your team, you don't know what's going on around you. So to give you a little bit of an overview what is happening, so it's nice to know what other people are doing. And then the other thing is also for the organizers to know, oh, there is a team that's very much stuck and might need help, and I know someone that can help them, right? So that's what the checkpoints are for. There's sometimes something like keynote presentations or some form of input. In this case, it was around pitching because, entrepreneurship events. So they wanted to teach people about how to pitch. And there's a final presentation, and you typically have some form of mentors running around. So in this case, again, related to business. So there were people that could help you with your business plan, with your design, with your marketing, things like that. And yeah, at the end, there was a jury that assessed all the projects, and then people could win stuff. And the stuff in this case was a startup bootcamp, but it can be all sorts of things. It starts from a colleague of mine, Jamie, likes to have as prizes little pieces from old hardware that they have decommissioned. So they have like an old supercomputer, and then you can win, I don't know, like a hard drive or whatever from that supercomputer, and that's your prize. And it can go up to hundreds of thousands of dollars depending on what kind of thing it is, right? But it doesn't have to be like that. It also doesn't necessarily have to have any price. It can also be, just for fun. So, but what does that now have to do with all this scientific community stuff that I was talking about in the beginning? Well, I said what we want to do is, one thing is to advance their code base, right? So we want to see what happens actually to the software. And we kind of approached it from the other side. So we looked at, okay, the people go to these hackathons and they develop something. What happens to all this stuff afterwards? Like, is it just being thrown away? Is it never used for anything anymore? So we did a study, a quantitative one, where we wanted to see how do hackathon projects get continued and which aspect can affect project continuation. For that, we used a website called DevPost. DevPost is, again, like a sort of American thing. So it came from there, has now spread also across other places. So you find hackathons, I don't know, in Latin America also, I would say. But it's still mainly like a Europe, US kind of thing. Why this is a good source is because people can promote their events there. So you can put like an event description. and say, I don't know, we have these prizes, we want you to work on this challenge, these are the people that are involved, all that kind of stuff. And then it helps you also to facilitate the background a little bit. So people can create project pages. They can say, this is our project that we worked on. Here's our little video. This is what we built it with. Here are the challenges. Here's our GitHub repository. And that's where it became interesting for us, because we know there are people that worked on this project at this event. Oh, and we also have participant pages. So you can then create a page for you and you can say, oh, I was in this project, I was in that project, I was in that project. So what we did is we mined this whole website, 73 hackathons, 500 something projects and participants, and we looked at what actually happens in their GitHub repositories after the event has ended. Is there anything at all? And yeah, I mean, predictable result a little bit. So what happens is very little. What happens is, okay, so there is at least one commit for more than a third of the events afterwards. So that's a good sign, right? So after the event has ended, more than a third of the projects actually committed to something. But that goes down quite quickly. If you look at the scale here, right? So it's sort of like until day 6, it kind of breaks down very quickly. So we were wondering, why is this the case? And what is sort of the predictors of this kind of short-term project continuation? And what is the predictor of long-term project continuation? And we found that they are very different. So first of all, short-term continuation was predicted by winning. So the teams that won something, they continued afterwards. The number of technologies they used. So the more different technologies they said they used, the more likely they continued after. And if they did some form of technical preparation, so meaning that they had created the repository already before and had already done something in this repository. So if you put all this together, what kind of impression does that create? So people that won something, that use a ton of different technologies and that prepared something, and they only worked for like 6 days afterwards. Okay. So if you take these things together, right? So you have short-term project continuation. So you have 6 days that people did something. And that was predicted by them winning something, by them using a lot of different technologies, and by them preparing what they wanted to create before. So the combination of that. I mean, to us, it looked very much like cleaning up. So it's like you wanted to build something, obviously, right? So you had some form of technical preparation. You won something, so that sounds like something that you might want to put on your resume afterwards, because, you know, you can say when you apply for a job, hey, I won at this hackathon, but then you don't want your repository to look bad. And during a hackathon, you only have a short period of time. So you need to kind of do some form of cleaning up afterwards. And the number of technologies, of course, also points towards that, because the more complicated it is and the more stuff you stick together, the harder it becomes to create anything coherent in a short period of time. Please come in. Okay. All right. And then we looked at long-term continuation. So from day 6 on until 6 months afterwards. And we saw that, first of all, the predictors are completely different, right? None of them that are here show up here again. 0. Hello, second person. Goodbye, second person. Here, it was about the average commit size. If you had a lot of activity until day 6, that kind of had the reverse prediction. So a lot of activity meant that there was not a long-term activity. Whether or not they wanted to expand their reach, so basically wanting to add new features, wanting to expand the user base of their tool, so really try to reach out to people to, you know, do something with it. Whether or not the skills that the team had actually matched what they wanted to build. So we looked at, people said, I know Python, the project is built in Python, right? So that's how we did this matching, and that it was a team that had diverse skills. So these were basically the findings for long-term project continuation. And there you can already see that, yeah, this must have been really some form of cleaning up, because then after they're cleaning up, they do a lot of activity here, and then nothing else happens afterwards. So this study now, of course, was limited to this one repository that the team created for the hackathon, and they continued working on it. But that is, of course, not what happens most of the time. What happens most of the time is you create a repository specifically for that, and then afterwards you might use stuff afterwards in a different repository. You copy it, you share it with other people, something like that. So we wanted to know, is there an effect that the code gets reused otherwise in some other place? Doesn't matter, not your repository, some other repository. So we did again use DevPost, and this time we first checked where does the code actually come from? Because a lot of the stuff is, of course, stitching existing code together, because, I mean, you have 24 hours. What are you going to do? You're going to take a ton of libraries, a ton of different stuff, and you just somehow cram it together and see what happens. And then we wanted to see, okay, where does this code actually get reused afterwards? And what we found is, of course, 85% was using existing code. So most of the stuff had been there before. Clear. 9%, 15% was own created code. I mean, the remaining, right? And 9% is newly created code during the event. 15% was your own code. So that means they reused their own code, not they used some other people's code. And then 9% was newly created code during the event. So about 10% of the code that we found there was during the event. And here, the number was a bit bigger and much more surprising, because in the previous one, we found very little reuse. But here we saw all of a sudden that about 30% of the code got reused. And we're only talking about this here, right? We're only talking about the newly created code, not the stuff that already existed. We're talking about the stuff that the people really created during this event. 30% of that we found in other places afterwards. Yes.
Hi. When you mean like the reuse of newly created codes, like the reuse is not based on like when they use existing codes, they create a logic using those existing codes.
Yes.
The reuse, you're not basing on like the ones that they just got all the ones that existed before and created a new logic.
No.
Okay.
Okay, so I should have said that. So when I say reuse, what we looked at files. So we looked on the file level. So let's say you had already started to develop something before, and you decided to create a new repository for the hackathon that you wanted to continue working on. And there you created, I don't know, 2 or 3 new files, new classes. So these files we saw showed up later at some other point. So we didn't look at what you already had. We only looked at what did you actually create during that event. Does that make it clear? All right, cool. So, and then of course we wanted to know, okay, what actually influences this code reuse? Well, it's number one, the number of technologies again. So the more complicated, the more likely it is to get reused. The team size, which I guess makes a lot of sense, right? I mean, if you have 20 people, then 20 people potentially can reuse that code afterwards and can tell other people about reusing that code afterwards. So that's very easy to see. Also, that there was an open source license, again, also makes sense, because if there is an open source license, then you know, okay, it's okay to use this code afterwards and I don't get into any trouble. And of course, also if they had some form of documentation, because just having the code is a little bit difficult, right? I mean, if you write a piece of code and you give that to someone and say, hey, you can use that now, and there's no documentation, it's going to be a little bit hard. So, but that is only the code side. Before I talked about basically the code, and then also about knowledge exchange. So people don't only need the code, they also need to know how to use it afterwards. They need to develop some form of common practices. So for that, what we did is we created for one very specific community a hackathon concept. Please come in, we don't bite. Thank you. And this is a resource called World of Code. What World of Code basically is a copy of GitHub. So everything that is in GitHub is also in World of Code. Now you could ask yourself, okay, why the hell would anyone do that? First of all, GitHub, of course, has a ton of restrictions in terms of what you can do with it, like quotas, right? So you can only run so many queries per day, per hour, per whatever, right? And then second of all, there are different things that you cannot do in GitHub, or at least not easily, because GitHub doesn't offer you that functionality. One example is the one that I just showed you before. This year, in GitHub, finding a file in any different repository, like you can go through forks, but if you don't have, if it wasn't forked, if it was just like I copied your code and then I copy it into my repository and just submit it there, GitHub wouldn't know. So they created an infrastructure around this where you can actually do this kind of stuff. They also have some more other fancy things, like, for example, if you have multiple GitHub accounts, they can merge them and you can say, okay, it's that person, right? So, but anyway, so they created this new resource, but now someone needed to use that and someone needed to learn how to use that. So what we did is we created a hackathon series for this. So we ran 6 events over 4 years, and we connected that to the larger software engineering community conferences, so ICFSE and stuff like that. Because we knew there are people that are interested in using this resource. It's that kind of community, right? Because they do research on GitHub. And we try to teach them how to use this sort of very specialized resource. So again, you know, connecting to the scientific software that I was talking about before, we really try to teach them, how do I use this thing for my science? And for that, of course, we did pre-event webinars, and we also had some people that knew this resource very well that could help the people during the hackathon. And the outcome was pretty nice, actually. We have like roughly 20 projects on various topics on, like, for example, reuse, again, the one that I showed you before. Some people studied bots in GitHub, so to try to identify which commit is actually coming from a bot versus coming from a human. They studied vulnerabilities and how they sort of propagate during different, through different repositories. They looked at innovation, and 7 papers so far have been published in higher level conferences on software engineering. So I would say that was a pretty nice success. And then the last topic is kind of expanding the community, right? Code, knowledge, community. And for that, we go to the high performance computing community. That was kind of my very first hackathon that I really co-organized, because wait, you can already see down here, we've done 19 events over 5 years. So that started in, oh, I think I'm lying. I think it's 6 years now, because the first one was in 2018, and if I count correctly, we're in 2024 now, right? So it's 6 years. Anyway, I'm not lying about the 19 events though. It was a 19. All right. So basically, what we did here is, again, we ran hackathons, but with a little bit of a different flavor. This time, we didn't let people just do whatever, because we had newcomers that came to this community. Most of them were students, and they were like, oh, can I use high performance computing somehow in any way? Or could that be a career for me? That was kind of the question. So they had no experience in this kind of stuff. So you can't just tell them, hey, here's a tutorial, and now you run your stuff on, I don't know, some Amazon Web Service kind of thing or something, right? So we needed to develop an event that kind of works better for these kinds of newcomers. So what we did is we reached out to community members. So we reached out to people that use high-performance computing during their regular work time and said, hey, do you have a problem that you want to solve? Or do you have something that some students can work on? And they then proposed these. So instead of the idea pitching, you had these community members proposing their topics, and then people could join. And these community members served as mentors during the entire time. So you had 3, 4, 5 people, and you had one community member there that could help them during the whole project. The team was still deciding what they wanted to do. So it wasn't like, here's your project, you work on this, you work on that, you work on that. It was like, here's a challenge. Can you help me with that? And then the community member tried to guide them towards developing something that works. And yeah, the focus was really on learning and engagement in this kind of event. Because to be fair, what they created is kind of simplistic. So there wasn't really a great output that could be used afterwards in terms of code. But these people learned something and they came back, right? So we have actually like references for careers. I put it in quotes because one career that we had was participant, mentor, organizer, internship at Microsoft. Right, so these kinds of careers we had, like people repeatedly participating and sort of going through the different levels. And of course, this whole thing was only possible because we had some form of funding for workforce development. So we kind of attached it to this thing that was already there. All right, yeah, and these are nice and little sweet anecdotal stories, of course. But now, of course, we want to have hard evidence. And here comes the disappointing part. I don't have any yet, because that is something that we're actually currently working on. What we are trying to figure out is, as we did with the code, we are not trying to look at now, does the code show up again afterwards? We're trying to look at, do the people show up again afterwards? So we are looking at, first of all, within DevPost. I'm not sure if this is really visible, this kind of little arrow here, right? So if people come to multiple hackathons, we want to see that. And for that, again, we use the DevPost database, which now is considerably larger because that was a different poll 2 years later. And then afterwards, we want to look at, does this actually lead to some form of onboarding to another community? So how does that actually connect to open source? And this is sort of the first result that I can show you that is here within DevPost participation. The points are people, and then the thicker the connection, the more common they went together to an event. So you can already see there's sort of like little clicks, but I can't really tell you that much about it yet because we're still in the process of repeated data cleaning because there's still some things showing up that we don't really like. So yeah, that's gonna happen in the near future. So in the end, what is still happening a lot is that you have people that come to these events. They come to hackathons, they participate, they join a project, and everything is great, and they like the idea. And we want to have something like this, which is we want out of this people to build communities, to exchange knowledge, to have some form of project continuation. But what we do with this actually most of the time is we leave that to this poor little hackathon participant kind of all by themselves. So there's very little integration into anything. It's oftentimes you come to the event, you do something, you have a good time, you learn a lot of stuff, you develop something interesting, you get to know people. But then afterwards, if something happens or not, in terms of these kinds of things, well, it's kind of up to you. So you go there and then there's very limited resources afterwards to actually do something with this. To help with that, we have developed a planning kit that you can find on, here's the website, the QR code works for that as well, that kind of collects all our resources together around hackathons. If you are an organizer, if you ever want to organize an event, then you will find information here of how to do that and also how to reach specific goals. The easiest thing is, where's my pointer? Because I can't reach up there, although I'm tall. This here is kind of the key. So we have identified 12 decisions that we think organizers need to make in order for people to in order for people to get out of the hackathon what they actually want to get out. Yeah, so kind of as a takeaway message, I talked about scientific software and the issues that they have, advancing a common code base, sharing knowledge, and expanding the community. And I tried to show you how hackathons can help in this sense. But of course, there's still a lot of things to do, right? So we don't know everything yet. I talked about different aspects of the event requiring different things. So I showed you different approaches of how these events are being organized. And I told you that the events necessarily have to be embedded in a larger strategy. So if you are a community and you want to do all these things, and you can't just say, hey, I organize one event and then afterwards everything is fine and we're all great and nothing needs to happen anymore. That is pretty obvious. Yeah, and then we also currently have a PhD position opening on exactly this topic. So on continuing this line of work, on looking at how do scientific communities develop software and how can we organize events for them that produces the outcome that they need, that it needs to produce. It's a fully funded position for 5 years. And it's in the Netherlands. And yeah, the previous student here of Kiev's likes it very much in the Netherlands. So maybe, I don't know, it's one of you, multiple of you, or any one of your friends might want to apply for that. If you have any questions about that, I'm also, of course, very happy to answer them. Finally, I wasn't sure if there are people here in the audience that have organized hackathons before. Yes, but you already know about this workshop, so it's kind of useless, but I say it anyway. We have a community event that happens once a year. This is the 4th edition of it. We're kind of iterating between Americas and Europe. And this time it's going to be in San Diego, where basically organizers and researchers of hackathons come together and discuss current challenges, exchange things that they have learned, and try to basically do what I've been talking about, build a scientific community around these kinds of events. Yeah, of course, all of this is not my work alone, right? I mean, there are tons of people that have contributed to this. The one that you know is this one. The one that you might know is this one. And for the other ones, I'm not sure. And this is also not all of them. So this is just a small selection of past and current contributors to this whole effort. And then, yeah, that's kind of it. I leave you with a picture of my cat because it looks good. And because we've also written a paper about her that has been published in the main conference on human-computer interaction. Is available in the ACM Digital Library. If you want to know more about that, I'm also happy to discuss this afterwards. If you want to know more information about me, you can look here. And yeah, thanks a lot for being here. Hey, I almost made it 40 minutes. Awesome.
Thank you, Alex. And if there's anyone who would like to ask a question, he wants to know when we're gonna have a scientific hackathon like this one here. So yeah,
When
we
here?
forgot to invite people from the hard sciences to come here, help them to.
Well, he knows how to organize them as well as I do. So you can do that here for sure. And I'm more than happy to help in any capacity. But you know, I'm on the other side of the world, so that's a little bit difficult.
I have a question about
Yes.
the continuation. This is something that we try to do here. We never publish anything, but the Open Data Hackathon of the city of Recife is, we realized that in the beginning that the projects would not be continued. So one of the things that were put in practice was stipends or temporary pays to finish the projects because they were mostly prototypes, and sort of helped. They continue with this idea, and it's part of their innovation cycle. That it's been the 11th edition this year. So do you see this monetary utility of like I have bills to pay, I need to have money? So do you think that this would help scientific software developing hackathons?
So this whole issue of funding is a very complex and a very difficult one. I mean, it starts with this idea that I talked about before about winning something. That's why I also said there are very different types of prizes, because it creates a certain atmosphere. It creates a certain expectation in a kind of event that you might or might not want to have, right? So that's kind of the start of it. Then when you think about the continuation afterwards, what you see often is that people show up with half-ready projects because they want to win, and then they kind of do the bare minimum afterwards just so that they can get the money out of it. And then also, this money only sort of serves as a short-term solution, because the money will run out at some point, right? It's not endless. You don't employ someone for like an infinite amount of months or whatever. You give them, I don't know, put amount X here that serves for the next 6 months or something, and then after 6 months you have the same problem, right? So sure, you get probably more mature stuff in the sense that in a short period of time you can only do so much. So you probably will get more mature things. But if you just give money, that will still not guarantee that something lives on afterwards. What guarantees living on afterwards much more is trying to figure out who can actually use this, who is this useful for, and how can we connect this to some form of existing infrastructure, to an existing community, to people that might be interested in that. We saw this, I couldn't present that here because I can't put everything that we have done in this context, but we did a study in Microsoft in 2019, where we studied their hackathon that they organize every year. And we looked at teams there, and we wanted to see which one of their projects survive. And one of the key contributing factors of survival was basically, number one, fit to anything that they have been doing already. So there was, I don't know, a product that could use an additional feature, and this feature fit. Or there was a team in the company that already wanted to develop something like this, and they kind of put it in that development pipeline. So that kind of helped to push this kind of stuff along. So unless there is a plan of actually building a community around it, or having continuous funding, or like pushing it to something that is already there, I find that a little bit difficult. Just throwing money at it won't cut it. You will just postpone the issue, at least in my understanding.
Another question? Okay. So, that's the microphone.
You said it like scientific software, something like it's a high level computing knowledge stuff. It's university researchers and things. But you said about creating a community. Do you think that like lowering the level of knowledge, like instead of creating a hackathons during like people that work in companies or are already out of university, do you think that bringing it back to like schools and creating an atmosphere at a younger age could contribute to it?
Yes, I'm just scrolling back because that is kind of an attempt in that direction. We didn't go quite down to school level, or we didn't go down to general public, but we went to, here are scientists that do really complicated stuff with high performance computing. And we put students, like bachelor students, in their first semesters of computer science, and we teamed those people up. So I would say that gap is already pretty wide in terms of knowledge. And they managed to learn something, and they managed to contribute something. And even more important, they got interested in this. So they thought, oh, this is something that I could do afterwards. This is something that would be cool for me. Right? So I can totally see that you use a format like this, even for, I don't know, some form of high school students, or also for the general public. I mean, there's also this approach of citizen science, which can fit perfectly well in this kind of stuff as well. Although citizen science oftentimes is kind of like collect some data for us and then we do something with it. So that's at least a common notion that you see often. But you could expand it. You could expand the participation opportunities. I think for me, it's always about kind of lowering the barrier, because this is, again, really complicated things, and high performance computing is something that I can at least remotely understand because I'm a computer scientist, but whatever these people in astronomy do, I have no idea, right? But still, there might be something that I know that might be useful for them. So kind of bringing these people together, I think, is still of value, even in that kind of format.
Any other questions about codes of conduct and hackathons?
Codes of conduct?
Yeah. I'm asking a question that he was supposed to ask.
Which one? Him?
Yeah.
Okay, go ahead. Wait, you need to be on YouTube too.
So have you some code of conduct for these events, or no anyway? Because this is my research and Kev is my co-advisor. Thank you.
So you're just poaching knowledge here. That's what's happening, right? Okay, so yes, we typically have code of conduct in an event. We don't have this many issues that you would typically see around code of conduct because the intellectual property, which is kind of one of the core things that oftentimes is in this code of conduct, is we make that very clear from the beginning. It's all open source. It's all available for everyone. No one monetizes this, right? It's just all available. Everyone can use whatever is being built. So that is one sort of key thing, right? So what happens to this stuff? Who owns the rights of this? But then, of course, also during the event, you want people to behave with each other. And we have used various different code of conducts. Typically, we reuse the ones that the institutions had that we organized the events at. Especially in the US, they're very strong about writing this kind of thing and having like websites and very like all these processes already set up. So we kind of attached ourselves to this. I don't know how that is here. Like, does anyone know how do you deal with that here? With code of conduct issues in Recife or Brazilian hackathons?
We, in terms of intellectual property, we usually recommend to be either shared or free to the, not free, but to be kept by the participants, or mostly shared with the organizer. There were some anecdotal evidence of hackathons trying to outsource knowledge by organizing a hackathon and like asking participants to give away their intellectual property, and it was not very nice. The community didn't see that as a nice thing. But in terms of code of conduct, it's mostly this, and some of them tell how to behave in terms of harassment and well, behavior as well, how you should behave in these events.
Yeah. So I can, if you want, I can share a code of conduct with you that we have used specifically for this on that website, because we have done so many events. We have our own like code of conduct. I can share that with you, what it contains. And it's really about, you know, just don't be an asshole, kind of like that, right? Of course, with all the details and stuff, you know, we're an inclusive event and no harassment and only take pictures when people agree to it and all these different aspects that you would want in a code of conduct. Regarding the intellectual property, I have one example where that was actually a hackathon where people could win a substantial amount of money, and they were then supposed to be continuing the project afterwards. So they got money in order to continue the project. But even with that, where it was clear, okay, so the intellectual property belongs to the team, to every member of this team. Even there, we had one issue with one team where afterwards, I don't know, they somehow didn't agree on stuff anymore. I don't know, because I wasn't there. But yeah, so divvying that up afterwards, like who owns what and like whose intellectual property is what, was really difficult. So yeah, that's why I typically like to stay out of this, and why I don't organize many corporate events, because that's of course where this kind of thing plays a much larger role. But with these communities where everything is really meant for open source afterwards, you just say, look here, CC share like license or something like that, or I don't know, MIT open source license or whatever license you want to pick. That's kind of what's happening. So if you don't like that, then either don't come or make sure that you don't share knowledge that you don't want to become in common domain.
All right, if anybody has no further questions, we also thank again Alexander for his talk. Thank you.
Thank you for coming.
Thank you. And we'll finish the transmission, I believe. Well, thanks again. And if there's any